आज हम करने वाले हैं लिक्विड सॉल्यूशन 12th ग्रेड फिज़िकल केमिस्ट्री का फर्स्ट चैप्टर है। चैप्टर काफ़ी सिंपल लेवल पर है, फिर भी हम चेक करते हैं कि किस तरह के क्वेश्चन इन्होंने 2026 जनवरी शिफ्ट में दिए हुए हैं। सो फर्स्ट क्वेश्चन है जेई मेन 2026 21 जनवरी शिफ्ट 2 पे पूछा गया है। द सब्सटेंस एक्स डिजॉल्व इन 150 ग्राम ऑफ द सॉल्वेंट वाई, मोलर मास 300 grams per mole, led to the elevation of the boiling point by 0.5 K. The relative lowering in the vapor pressure of solvent is this. Kb is given. Assume the solution to be diluted and no association and dissociation take place. Fine. So this is the question of the colligative property. First we can go with the delta Tb equal to Kb into m. So Kb is given 5 and the molality of the reaction, that is the X is 1.5 gram dissolved substance divided by the molar mass, and the solvent mass is given 150 10 to power minus 3. Delta Tb value is given 0.5. So on solving this, 0.5 into 150 10 to power minus 3 would be equal to 5 into 1.5 by m. So we will get the molar mass would be is equal to 100 gram per mole. Now based on that we can apply the relative lowering of vapor pressure, that is would be equal to X of solute. So moles of solute is 1.5 by 100 by the total moles. Total moles is how much? That is the 150 by 300. So we will get it approximate value 0.0291, which is quite equivalent to 3 into 10 to power minus 2. So 3 should be the answer. Let's move to the second question, that is 21st January shift 2 पर पूछा गया है. Osmotic pressure of the living cell is 12 atm at 300 Kelvin. The strength of the sodium chloride solution, that is isotonic with the living cell at this temperature is, R is given 0.08. Assume complete dissociation of NaCl. So for osmotic pressure we know that pi is equal to ICRT. The living cell has osmotic pressure 12 and it is isotonic NaCl solution. So that osmotic pressure of NaCl and osmotic pressure of the living cell, that should be same at isotonic point. Since this is the complete dissociation they are saying, so I value is 2, that we will write the C and R and T, and here that is I value is 1 for this and CRT. So anyway they have given the 12 atm directly, we can apply the 12 atm directly. So 2 into C, R value 0.08 as they have given 0.08, temperature is 300 would be equal to 12. So the concentration we can get it 0.25 moles per liter, but they ask the question in the grams per liter, so we have to multiply their molar mass 0.25 into NaCl molar mass is 58.5, so we will get the answer around 15 grams per liter. Simple question. 23rd January shift 1 पर है question number 3. Which one of the following graph accurately represent the plot of partial pressure of CS2 as a small fraction in the mixture of acetone and CS2 at constant temperature? So here the options are missing, but we will identify. They have given all the 4 graphs and positive deviation graph, negative deviation graph or ideal solution graph. So since CS2, when you are treating with the acetone, so it will show the positive deviation, and positive deviation graph is like this way. This is the Raoult's graph. This side is acetone and that side is a CS2. The mole fraction of acetone is higher there, and here the mole fraction of CS2 is higher, and this is the acetone vapor pressure and this side is a CS2 vapor pressure. So since this is the positive deviation, so graph look like that way. So here according to the graph option, that answer 1 should be the right. Now question 4, 28 January shift 2 पर पूछा गया है. Consider the following aqueous solution. 2.2 gram glucose in 125 ml of solution. So these many values are giving the correct increasing order of boiling point of these situation. So delta Tb would be is equal to IKb into m. So Kb will remain same because solvent is same, water is there. In glucose the I value is 1 and molality would be 2.2 by 180 divided by 125 into 10 to the power minus 3. I'm using here molarity because very diluted solution, that molality and molarity is both are same. Calcium chloride के लिए CaCl2, the I value is 3, it's 1.9 by 111 molar mass, and the solvent is 250 ml, so 250 into 10 to power minus 3. Similarly, we can go for the urea. Urea is I value is 1, so 9 by 60 by 500 into 10 to power minus 3. For aluminium sulfate, that is the Al2SO4 whole thrice, so we will have the I value 5, and that is 20.5 by molar mass is 342 divide by 750 10 to power minus 3. Question thoda lengthy ho gaya because we have to solve all this such thing. Based on calculation, we got it, that is aluminium sulfate having the highest one. So 4 number having the highest, all 3 option is giving the 4 number. After 4 we have a third number, that is the urea, this one, and then we have a second number, that is calcium, and glucose have the least one. So fully calculation based question that we have to do it. Question 5, 24 January shift 2 पर है. At 298 Kelvin, mole percentage of N2 in air is 80%. Water is in equilibrium with air at pressure of 10 atm. What is the mole fraction of N2 in water at 298? KH is given this. So we will apply the Dalton's partial pressure law. Pressure of nitrogen would be is equal to mole fraction of nitrogen into PT in vapor phase, where the mole fraction of nitrogen is given 80 means 0.8, and the total pressure is given, that is 10. So we will get the 8 atm, and 760 mm of mercury we will apply, so we will get it 6080 mm of mercury. Now we have to find out the mole fraction of nitrogen in water. So Henry's law, P nitrogen KH into mole fraction of nitrogen in liquid. This was for gas, in gas. So that is 6080. KH value is given 6.5 10 to power 7 into mole fraction of nitrogen. So we will get to know the answer 9.35 10 to power minus 5. This is the mole fraction of nitrogen, so we will get the fourth answer. Here in the third option they have given plus 5, so that's why we have ignored. Now next question we have, that is the JEE main 2026 24 January shift 2 पर पूछा गया है. Two liquid A and B form an ideal solution at a temperature T Kelvin. The vapor pressure of pure A and B are 15 and 55. What is the mole fraction of A in solution of A and B in equilibrium with the vapor in which the mole fraction of A is 0.8? So we know that in vapor phase the YA should be is equal to PA naught XA by PT. So that value is given 0.8 in the question, that mole fraction of A in the vapor phase. PA naught is given 55, XA we have to identify, and PT total pressure. We can write PA naught XA, P naught B, XP. So we will have the 55 XA. Now PA naught is given 55 and PV naught is given 15. So 55 XA plus 15, 1 minus XA. XB ko we can write 1 minus XA. Now on calculation XA value we are getting, that is 0.5217. Answer should be C. 22nd January shift 2 पर क्वेश्चन है. 100 gram 98% H2SO4 aqueous solution mixed with 100 gram 49% H2SO4 aqueous solution. What is the mole fraction of H2SO4 in the resulting mixture? Solution they have given 100 gram of 98%. So 100 into 98 by 100, that will give us the 98 gram of H2SO4 in solution 1. So the moles would be is equal to given mass divided by the molar mass, 98 by 98, we will get it the 1 mole. In second solution it's given 49%. So 100 का 49% कितना हो गया? 49 itself. तो इसके मोल्स कितने हो जाएंगे? 49 by 98 means 0.5 moles. तो total moles of H2SO4 we got at 1.5. So mole fraction of H2SO4. The moles of H2SO4 is 1.5 divided by 1.5 plus. So in this question 100 gram H2SO4 we got it. So 100 minus 2 gram H2O we have, and here 49 gram H2SO4, so 100 minus 49, that we will get it 51 gram of the water. So total water quantity is 2 plus 51 means 53 by 18. So on calculation you will get it, that is 0.337. Your answer should be C. So 22nd January shift 1 का question है, consider the solution of CO2 dissolved in water in closed container. Which one of the following plot correctly represent the variation of log partial pressure of CO2 in vapor phase above water with log mole fraction of CO2 in water? So these options were given. So option was the graph, तो मैंने separately लिख लिया है. Now let's find out which graph is right. So CO2 in vapor phase is given on y-axis in the question, and mole fraction of CO2 in water is given in x-axis. So that was the mole fraction, and this side is a vapor pressure. So Henry, we know that P is equal to Kh into mole fraction of CO2. Let's say they said to take the log. So let's do the log both the side. So log of P would be equal to log of Kh plus log of x of CO2. So with y is equal to mx plus c से intercept will be is equal to log of Kh. So that could be intercept log of Kh. Rest is the equation. So that should be the answer. Second is the right answer. 22nd January shift 1 पर है statement based question. Henry law constant Kh is constant with respect to the variation in solution concentration over the range for which of the solution is ideally diluted. तो बेसिकली ये सही हो चुका है because Henry law constant depend only on temperature and the nature of solute solvent interaction for ideal diluted solution. It is completely free from the different concentration within the diluted range. So that should be right. Kh does not differ for the same solute in the different solvent. This is false. Second one is false. Henry law constant is a solvent base. So same gas or solute has a different Kh value if we are dissolving into the different solvent. So one is true and second is false. 23rd January shift 2 का question. Two liquid A and B form an ideal solution. At 320 Kelvin, vapor pressure of solution containing 3 mole of A and 1 mole of B at 500 mm of mercury. At the same temperature, if 1 mole of A is further added to this solution, the vapor pressure of solution increased by 20 mm. The vapor pressure of B we have to find out. We will apply the Raoult's law. So we have Pt is equal to Pa naught Xa plus Pv naught Xb. First stage it is given 500 mm of mercury. We will write the 500. Pa naught is not given. Xa is 3 by total moles, 3 plus 1 plus Pv naught, that should be 1 upon 3 plus 1. So we got it 500, 3 Pa naught by 4 plus 1 by 4 Pv naught. Similar pattern we can go for the second equation. They said it increased by 20 mm, so total is become 520. And how much extra we added? 1 mole of A we added extra. So we got it 4 by 5 Pa naught, and this become Pv is 1 by 5 Pv naught. So on solving this equation, this is the two different equation we got it. Equation number 1 and equation number 2 separately mathematically we can calculate the Pa naught and Pv naught value. So on calculation Pa naught value we are getting, that is 600, and Pv naught we will get it 200 mm of mercury. So question 11, 21st January shift 1 पे question है. Element P and Q form two type of non-volatile non-ionizable compound PQ and PQ2. When 1 gram of PQ dissolved in 50 gram of solvent, delta TB was this. When 1 gram of PQ2 is dissolved in 50 gram of solvent, delta TB was this. Kb is given. We have to find out the molar mass of P and Q. So we know that delta TB would be is equal to IKB into M. Since it's a non-volatile, non-ionizable, so I value is automatically will be 1. So we get the Kb into M. So for the first case, the TB is 1.0 176 equal to Kb5, molality is given for the first case, 1 gram of PQ divided by the molar mass of PQ, and mass of solvent we have 50 into 10 to power minus 3. Similar pattern we can apply for the PQ2, that is the 0.689 would be is equal to Kb is given 5 and the mass of the PQ2 is given 1 gram, divide by the molar mass of PQ2, divide by the solvent 50 into 10 to power minus 3. So on solving this equation we will get the mass of PQ, that is 85, PQ2 145 grams per mole. Now we have to identify the molar mass of P and Q. तो separately P plus Q का molar mass आ चुका है 85 and P plus 2Q का molar mass आ चुका है, that is 145. You can solve, this is equation 1 and equation 2 mathematically when you are solving. So P का value आ रहा है 25 and the Q value is coming 60. So 25 or 60, that third should be the right answer. So 28 January shift 1 पर है, 2 moles of liquid A and 3 moles of liquid B. The vapor pressure of ideal solution is 320. At this stage, 1 mole of A and 1 mole of B are added to the solution. The vapor pressure is now measured as 328.6 mm of mercury. So the vapor pressure of A and B respectively. So what we can do, PT would be is equal to PA naught XA plus PV naught XB. Now PT initially is given 320. PA naught 2 moles of A divided by the total moles. XB is 3 divided by the total moles. Equation 1. Now in the second stage, 1 mole of A and 1 mole of B are added. So PA naught, now total moles is 2 and 1. So 3 by 2 plus 3 plus 1. PV naught. Okay, B is also added. So B initially we have 3, now 1 mole extra we add up, so this becomes 4. So 2 plus 3 plus 1 plus 1. That is the equation number 2, and here it's measured 328.6. So when you solve this question, you will get the value of the PA naught and PV naught. So PA naught is coming 500 and PV naught is coming 200. That should be answer. तो ये क्वेश्चन सिमिलर ही था जो अभी हमने पहले भी किया था. So that question was similar like a question number 10. Overall question easy ही आ रहे हैं. Question 13. 24 January shift 1 पर है. A solution is prepared by dissolving 0.3 gram of non-volatile non-electrolyte solute A of molar mass 60 and 0.9 gram non-volatile non-electrolyte solute B of molar mass 180 in 100 ml of H2O. The osmotic pressure of solution will be. So pi should be is equal to ICRT, but since these are the non-volatile non-electrolyte is given, so I value is 1. So we will have the, I'll write here total concentration C1 and C2 because A we are adding and B also we are adding, and this is R and T. So A we have 0.3 gram divided by the molar mass is 60. Similarly for B, that is the 0.9 gram and the molar mass is 180 in 100 ml solution. So I'll write here divide by 100 10 to the power minus 3. And the R value is 0.082. Temperature is given 27 degrees Celsius, so it becomes 300 Kelvin. So on calculation you will get it 2.46 atmospheric pressure. 24 January shift 1. W gram non-electrolyte non-volatile solid, molar mass M, dissolve in 100 ml water, decrease vapor pressure of water from 640 to 600 mm mercury. If aqueous solution of electrolyte boil at 375 and Kb of water is this, then the mole fraction of electrolyte solute in the solution can be. See, this is the non-volatile, but it's an electrolyte, so definitely it will dissociate into the ions. So we can write the delta Tb would be equal to I Kb into M. Even the relative lowering of vapor pressure is also support the I into Xb, means mole fraction of solute. Mole fraction of the electrolyte we have to find out, means Xv value we have to identify. So what we can do, we can calculate I from this case, delta TB by KB into M, and we can put up here in this equation delta TB by KB into M into XB. Then we will get to know the answer. So P naught is given, that is the 640, PS is given 600, that is 640, and that should be delta TB value is given here 375. It boils, so means delta TB is TS minus T naught, so 375 minus 373. KB value is also given 0.52. Molality is would be W by molar mass. So 100 ml would be equal to 100 gram into 10 to power minus 3 and mole fraction of B. So on calculation, XB value, you will get it 3.8 by 8 into W by M. That should be answer. So your answer match with the 0.8 by 8 W by M, 3. So this is all about the liquid solution. 14 क्वेश्चन पूछे गए थे सारी शिफ्ट जनवरी शिफ्ट को मिलाकर. क्वेश्चंस वर प्रिटी सिंपल, हर एक क्वेश्चन डूएबल था, तो इस चैप्टर को अच्छे से प्रिपेयर कर लेना है. थैंक यू सो मच. Best of luck for the April shift.